If you are a developer or an infrastructure engineer and you often context switch between projects you are working on, these 4 command line tools will save you a lot of time, like they did for me. These 4 tools play nicely together and you can combine them to multiply their efficiency. I bet you have so many open tabs in your browser that it would take ages to go over them one by one. This is the nature of modern life and modern work. You have to juggle tons of different projects, switching between them throughout the day. And in terminal means going from one project to another typically means setting up environment variables, exporting secrets, maybe also configuring SSH agent or kubectl, and selecting a specific version of a programming language. And if you have to deal with Python, there is also a virtual env management zoo waiting for you. Your machine learning colleagues probably prefer Conda. Back in folks swear by poetry or pipenv, and then there is definitely some legacy project which is based on manually created venv, so don't forget to source activate. I don't know about you, but for me context switching between projects is a productivity killer number 1. That is why direnv is a part of my terminal toolbox. It makes hopping from one project to another as seamless as possible. You just drop a .env.rc file in a project directory, and whenever you cd to that directory, all of the configured project-specific changes are getting loaded into your shell session. Here's a Hello World Node.js project that I'm going to deploy someday to my local Kubernetes cluster. Let's cd to that project directory. I've prepared a .env.rc there already. See? This is really important. Direnv won't do anything without my permission. I have to give an explicit approval for this particular .env.rc file contents. If I change my .env.rc later, I would have to give another approval. Okay, from the output you can see that direnv adjusted the path environment variable, and from the shell prompt you can see that my kubectl context was set to minikube, and the default Kubernetes namespace in this shell from now on is hello world. This is what I have in the actual .env.rc file. This is essentially a shell script. You can simply put exports here, or you can call one of the direnv provided standard library functions, like for example this layout node here. This line simply adds node modules.bin to the path, and then you can also call side effects producing commands like I do here to set my kubectl context and namespace. Watch file library function, by the way, tells direnv to reload .env.rc whenever watched file changes. This is super useful. So how does this magic work? Direnv piggybacks on the mechanism your shell provides to update the command prompt after each command execution. Yeah, that prompt which typically shows you your current directory and a $sign. All the cool projects out there that decorate your shell with fancy metrics, all of them hook into that same mechanism. So if direnv finds a .env.rc file, which was approved before of course, it then goes and forks a subshell, loads .env.rc in that new subshell, figures out what environment variables have changed there compared to the original shell, and then introduces those changes in your original shell. All this trickery allows you to quickly reconfigure your terminal environment when you enter a project directory. As a result, you don't waste your energy on unproductive work and instead can focus on interesting stuff. Dear dudes and dudettes, please check out the code from the description below this video for one more direnv project configuration example. I have Python with poetry for you there.
I mean, everyone talks about how awesome it is.
If you, like me, spend most of the time in a terminal, you probably know that terminal multiplexer like Screen or Tmux is. In a nutshell, it's like your browser with tabs. You can close your browser and then start it up again. And all your tabs, even reading positions on open pages, are restored. So it is with Tmax or Screen. You have multiple shells where you can do different things, all under the same terminal multiplexer session umbrella. You can run terminal multiplexer locally on your laptop, or you can SSH to a remote server and run it there. In both cases, if you close your terminal application or drop your SSH connection, your existing session with all the shells will be preserved, so you can go back to it later, just like with a browser. The question is, how do you quickly set up a new session for this particular project with predefined commands running each in its own tab, so that you have, for example, a code editor in the first window, Docker Compose in the second, and tail-f with container logs in the third one. This is where smug comes into play. Not sure about the choice of the name for the project, but from the practical point of view, it's almost perfect. It's not getting in your way, does one thing and does it well. Without any further ceremony, here's the demo. I decided to combine smug with the tool I've shown you before, direnv. So if I just cd to the project directory, smug will fire up Tmax with a bunch of windows there. Note that if you're in a Tmax session already, nothing will happen. For this demo I have the most basic smug setup ever. But in fact you can do a lot more. For example, you can split a window horizontally and have your code editor and logs output side by side. One of the most interesting features, in my opinion, is configured with the stop keyword. You can set a command that will be executed when you've closed all the Tmax windows. This is the way to do some kind of a cleanup, for example, to shut down a background process. Smug is an easy to set up and solid tool to manage project-related Tmax sessions.
It's like a plumbing tool or something.
As much as we want to be on the creative side all the time, there's still a good number of mundane, repeatable tasks that just have to be done. Up until recently, I especially disliked having to set up a new CloudFormation project. I had to go over my old projects looking for a good readme to copy-paste its structure, then a proper git ignore file, and the very starter template YAML, to name just a few things that I needed. Every time I said to myself, next time I will put all of these good files aside and just copy them to an empty directory for a new project. You've guessed it, never done that. Now imagine a different situation. You have a number of repositories, let's say for AWS Lambda functions, all of them already bootstrapped from a golden image kind of blueprint. And now your team decides to introduce, let's say, common standards for indentation across all of these repos. You know you can git add an editor config in each one of them, but what if instead you could update your golden image kind blueprint and synchronize Lambda functions projects with it? This is what Copier can do. And you know, a demo is worth 1,000 words. Here is my golden image kind blueprint directory. Such a directory is what Copier calls a template. For it to be recognized as a template, you need a file which Copier calls a questionnaire. This is a YAML document that lists variables required by Copier to take your template and scaffold a new project from it. As you can see, here is a simple input check-in and a text message that is shown to a user to get the value for a variable. Of course, you can also pass these values in a script. Here's how Copier looks in action. I want the template in the current directory to be used for a new project. Lambda function name. Of course it's full. Here's what copier has done. All the project files are in place, but what's more important, in this Docker file, for example, I have the Lambda name from the questionnaire put in the right places. Let me show you the template directory again. See? These nice curlies can be used in files or directory names, and if a file name ends up with Jinja, such mustachy placeholders will be replaced in file's contents as well, just like here. From this dockerfile.jinja template, Copier has rendered a tailor-made Docker file for the project. If you know another tool quite popular in Python community called cookie cutter, everything I've shown you so far doesn't look too interesting. What I'm going to present now is the Copier's feature that you will not find in cookie cutter. Cookie cutter does not provide anything to help you with the day 2 problem, maintenance and updates. To make updates work with Copier, you need 4 prerequisites. First, you have to put a file with a weird name. And predefined content in the template directory. Second, your template has to be in a separate Git repository. Third, your destination project has to be managed with Git as well. And fourth, you need to use Git tags to label template releases. Doesn't seem too complicated, right? I've prepared a separate Git repo for the template already. The answers file is in place, and there is one release tag already. Let's generate a project from this template. Answering the question and checking the result. Now, for updates to work, let me first create a Git repository in our new project directory. Alright, just running Copier update now will allow us to re-evaluate our questionnaire answers. What is your Lambda function name? Bar. No changes. But let me do a new template release. I would just add a comment to this Docker file I have in the project directory. Copier solves two dev/ops project management problems. 1. Bootstrapping a project from a well-defined blueprint with support for templating files and directory names, as well as files contents. And 2. Maintaining project updates with regards to blueprint evolution.
Oh man, that's incredible.
Now I have to warn you, if you hold a hammer, everything around you looks like a nail. This is what happened to me. I've used this half-a-century-old technology everywhere. I started every new project with it. Even more, some projects were entirely built upon this technology. I'm talking about Make. In the past, I would initialize an empty Git repository not with a README, but with a Make file. There I would put all the automation I expect to need for the project. Such a make file would serve me in my local development and later in a CI/CD pipeline as well. I would typically have targets like test to run all kinds of linters on the code and configs in the project directory deps to install the required dependencies, maybe also build to package the project. It can be a Docker image, for example, and of course deploy to, you guessed it, deliver the project to cloud. With time, this make file would grow. I would add more project-specific targets, all kinds of reusable code snippets would go there. If I need to bring up port forwarding for database connection, there you go. I need to run kubectl top for a particular namespace, sure. I need to tail logs for a particular deployment, new target is immediately added to the make file. But you see, make files were not really designed for automation of this kind. The syntax is not like anything else you would use in your daily work. It's actually quite quirky, to be honest. If you want to code longer scripts, you end up having to put semicolons and backslashes at the end of each line, and you also have to escape the all too common $sign. On top of that, if you happen to have a complex make file with lots of dependencies between targets, good luck having to decipher make error messages. This is the reason why make has the -d option. Of course, you might argue that I'm whining, stupid little dude misusing half-a-century-old technology, and yes, I do agree. What I described just a minute ago can be considered as misuse.
Like this. What the f?
After all, Make is a build system. But more importantly, there is a much better tool for the job. The tool that I'm using now instead of Make is called Just. Yeah. Instead of Make files, I write Just files now. Okay, so what's so special about Just? First of all, with the -l option, it can print a list of recipes. Although I have a habit of using easily guessable names like test, build, deploy, -l is really useful when you jump between projects and want to run some automation quickly. Just -l, get a list, run a command, bang, done. If you put a command above your recipe definition, it will be printed out as the recipe description. Comments are finally useful. This is how you define variables in Just. And this is how you use them. That's pleasing. If you have a variable undefined, Just will not run, warning you of an issue. Remember I said that writing longer scripts in make files is a pain. That's because each line in the target executes in a separate subshell, and if you set a variable in one line, that variable is not there anymore on the next line. If you need a for loop, you inevitably end up with bloody semicolons and backslashes. Not so with Just. Look at this recipe side by side with its makefile version. You may have guessed it, because of the shebang, you can actually write your recipes in any other scripting language. Right now I'm experimenting with Stickle, so here's one more example for you. And now comes the feature of Just I appreciate the most, because there's simply no way to do the same with Make. In a just file, you can add parameters to your recipes. This is how it looks like. You have a recipe name as usual, and what follows up to the colon are recipe parameter names separated by spaces. And here's how you pass parameters to your recipe dependencies. These recipes with private annotation are not callable from the command line and are meant to be used as a dependency only. And by the way, you don't have to use tabs for recipe bodies. If you prefer spaces, that's okay. When it comes to installation, there are tons of ready-made packages for different Linux distributions, for macOS, for FreeBSD, for Windows. And because just is a single binary without external dependencies, you don't need no super user permissions. You can just drop just anywhere where your path environment variable points to. This can be handy for some restricted CI systems, for example. Syntax highlighting support is also available for all kinds of editors, including of course terminal ones. Just is much better make if you need a task runner, and it will definitely save you time when you have to run certain project related commands repeatedly. Good people, if you have questions, don't hesitate to ask them in comments below this video, and I will do my best to answer all of them. Thank you, and see you next time.